Said it. I lied. Okay. How are we feeling about it? Honestly, you guys did pretty good. Not too bad. Maybe not enough time on it. That's okay. We'll give you more time. Next time or less problems, something like that. How, looking at your answers, do you see, you're like, oh, that makes sense where I messed up. It happens. One thing I forgot to mention is, let's say I don't know the reaction. Let's say it's, all right, 4, 2, 2, 4. We want the lowest it can be. So if it's 4, 2, 2, 4, well, I can divide all of these by 2, and I'll get the same thing. So, ooh, it's going to be a tough one to do that. Let's say potassium chloride. There we go. Easy one. Also, some of you forgot that, oops, that's not a C. That's a C. Cl2, you have to make it diatomic. Don't forget that. That's like, it throws everything off. Don't forget, which ones have to be diatomic? HNOF, yep. Cl. 2 more. Br and I. Those all have to be diatomic. Does everybody know what that means? Except for you? What does it mean? It doesn't mean it has a +2 charge. So H, marker's running out. H, N, O, F, Cl, B, R, and I are all diatomic. Di means 2. They all have to have 2 when they're alone. Does that make sense? Don't forget the 2 when they're alone. If it's HCl, you don't have to put a 2 because it's just 1. But when it's alone, just floating out as a gas, it's a 2. Cool. Okay, let's go back to my other point. Let's go KCl, KCl, K plus Cl. Is anything wrong with that one? No? I have to add a 2. That's right. 2. Okay, so let's say I put KCl. I've got 2 over here. I've got 1, 1, 1. Let's say I start with 2 for some reason. I start with this one. I multiply this by 2. Well, that makes it a 4. So now I know I have to have 4 over here. That makes that a 4, that a 4. And then, since I have 4 over here, I have to multiply this by 4, make this a 4. They all equal, don't they? Yeah, right? They're all the same. And it would be 4, 4, 2, right? We want it in the lowest number it can be. So what can I divide all of those by to still have whole numbers? I can divide them all by 2. So it'd be 2, 2, 1. And this is what we want, 2, 2, 1, not 4, 4, 2. We could also have 6, 6, 3. So if you can divide it by 3. You could have 10, 10, 5, whatever. Just divide it to the lowest possible. And it shouldn't be hard to pick up. You can say, oh, those are all even. I can divide them by 2. Something like that. Cool? Does that make sense? Guys, shh. Let's do another one. I don't like this marker. I saw most people got this wrong. I think maybe 2 people got it right. It is on the front page, on some people's. It's nickel plus H hydrogen chloride equals nickel Cl3 nickel chloride plus. All right, let's do this. Does somebody want to come up here and do this? Does anybody want to come up here and do this? All right. You guys want to do this? Is that what I'm hearing? I don't know. I hear them talking, so they must be talking about it. Want to do it on the board? No? Okay. Let's be quiet then. Anybody? It's on your sheet. I put down your answers on your sheet. It's on your sheet. I know everybody has this one. Your quiz. It's on your quiz. There you go, Anya. Here, give me 1 sec so I can pause it and I don't get in trouble. No. You got one? Okay, 1 sec. Let me erase it. Well, let's do it anyway. I got to kill time. No. C5H12. Oop. Okay. Who wants to do this one? Haley wants to do this one. Does anybody want to do this one? I mean, does Layla want to do this one? She was talking, so I must be talking about this. I don't know what else could be as interesting. Michonne? Oh, all right. Taryn? He was talking about it, I heard. Who wants to do this one? Anybody? Anybody but Anya? Nobody? All right, then you guys will have to walk me through it as I do it. Start with carbon. Yep. 5 to carbon. Makes this what? How many oxygen? Over here. 10 plus 1 is 11. Cool? Well, let's just move to hydrogen next. Let's get our hydrogen to 12, right? How do I do that? 6 in front of H2O. That gives me 12. And then I got 6 oxygen, so 10 plus 6 is 16. And then how do I get my oxygen to balance? 8. 16. So it's 1, 8, 5, 6. Cool?
We want to help you out here. What would happen if you had C2?
Oh, we haven't talked about this before. Let me draw this up here.
What type of reaction do you think that might be?
Oh.
Talk about that,
We talked about what kind of reaction it would be.
Second combustion reaction, because that means you're having a fuel that's burning. But what about if you had C2H6? Okay. Do you think, would you rather balance that one or C6? C9H20. Put that one below it there. C9H20.
Which one would you prefer to do? The top or the bottom? This one has 2 carbon and 6 hydrogen, 9 carbon and 20 hydrogen. The top, you'd think. And we haven't talked about this rule yet.
So, because one of the things I'd like to make reference to, a lot of you do play basketball, right? So, what is the point guard's responsibility when bringing the ball up the court and try to recognize the defense is either what or what? Zone or man-to-man defense, okay? So you're doing something here too. We want you to recognize this is like taking the difference between a man and a zone defense. I myself, I would rather do the bottom one, okay? So this is where we just take a logical approach how you might do that top one. Is once you recognize this pattern, it makes things a lot easier. And sorry to interrupt.
No, that's fantastic. Well, let's do the top one just how we normally do. CHO. Got 2, 6, 2, 1, 2, 3. All right, everybody pay attention. This is important. So let's just do it. I'll do it for you. So we got 2 carbon. I'm going to double it over here. 2. I got 4 plus 1 is 5. And then let's go to our hydrogen. So let's do this 3 to get 6 over here. 3 times, so that's 8. So, yep, 2 times 2 is 4. Oh, 7, excuse me. Bad math. 7. Is there any way to get 7 out of here? Is there any way to get 7 on this side? No? Is that what you're saying? Can I multiply anything by 2 to get 7? No. So 3 doesn't work. What should we do now? Now we are stuck. So, 2, 1. Get rid of the 3. Well, how do I do that? Anybody know? You can't? Oh, it's the glares. Glare's bad. It might be the marker too. So good this marker. That's a good marker. I'll finish the problem. What should we do?
Times it by 3.2.
3.2. No.
3.5.
3.5. I know what you meant. No, we can't do 3.5 because we can't do halves for this. There's no. It's only whole numbers. But that's a good point. I don't like that.
That's the only way we can work.
Well, that's not true. Here's a rule that I want you all to remember. When the carbon is even, the first one, we're paying attention? When this carbon is even, we're always going to double it every single time. You double it. And because that's the only way for it to work out. So funny. Nothing? Okay, so we have to double it. So we doubled it. It's 4. 2 times 6 is 12. Let's get rid of this. 1. Hydrogen's 2, and then this is 3. So we have to double it every single time. Double this. If this is even, we got to double it in a combustion reaction. So we got 4 now. Let's make it 4 on this side. So put in a 4. 4 times 8. 8 plus 1 is 9. And then let's make our hydrogens even. So 2 times 6 is 12. And then 6 plus 8 is 14. 6 plus 8 is 14. And then, how do we finish this out? Multiply our oxygen by 7. Boom. So we got to double it every time. It doesn't work out if we don't double it. Make sense? Okay. Now let's do something new. What are we doing? Is there, oh, I got a mark on. Told me. Thanks, guys.
Well, I told you that's.
Oh, you did? Oh, thanks. I get it.
What?
I get it.
Yeah, you got it.
Oh,
Just
thank you.
saw it.
I appreciate it. Appreciate the help. Yeah, geez, thanks. Maybe we will have that quiz tomorrow.
Give it to us right now.
Hey, look at that. We're all good.
I'm gonna go get that on the live stream.
Oh, it's on there. It's on there now. Maybe I'll just not post it.
No, Rylan wants to see it. And Chris will.
Oh, shame. Okay. This is our next quiz. This is what we'll be doing. And quite a few people got this wrong. One similar to this. Let's go lithium fluoride. No, this is the wrong one. I didn't want to use this one. Ooh, All right, do this on your own. This reaction. And right here, I want you to put what kind of reaction in this box. What kind of reaction is happening here? We've talked about this before. Give it a shot. Do it on the board. Get your notebooks out. Use scrap paper then. What? That square, I want you to put what kind of reaction is happening there. What?
What does that mean?
What kind of reaction it is? So we had synthesis, decomposition, combustion, single replacement, and double replacement. Those are the 5. We have 5. What is it? That's for you to decide.
It's 2-2.
It is 2-2-1. So use one of. Is it a synthesis, a decomposition, a single replacement, a double replacement, or a combustion? I'll tell you. Yeah, it'd be a +1.
Wait, do I even need the charge?
Yeah, you do on this. So like lithium fluoride, it'd be plus. You don't need it, but it tells you.
And then, what do we put? Do I put plus?
No, just fluorine. Just put an F. And that's a -1.
Then is it the arrow?
Arrow.
And then
Yep.
don't we do it backwards or something?
Then it would be lithium plus fluoride, fluorine. But remember, fluorine's a gas. Fluorine, yep. And remember, it's a gas, so it's diatomic. Yes, ma'am. Yes, you do. Well, you got fluorine chloride. It'd just be fluorine. And I would recommend putting, so LIF, arrow, Li plus F2. That's how I would write it. Yes? Just right, because the charge is, it's a +1 and a -1, so you don't need any extras on either side. So they cancel. Yep, so it'd be 1, 2, 3. And I can do it on the board for you if you're lost. I will do it on the board, I should say. How you doing? Well, what's lithium fluoride? Yeah, well, I'm sure Anya would let you borrow it. You guys getting it? Yeah, right. Yeah.
Why is there 2 numbers?
What?
How come we don't have like these numbers down here?
No, it'd be down. Okay, what are we doing? One, two,
So confused. Yeah, there isn't. Did I miss?
I'll set it up. Oh, that's right. You were gone, so you might be a little bit lost. So we put 2 right there because it's economic. Because we've talked about it a couple times. So no matter what, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, all the pink ones I guess you have, those are all going to be, if they're alone, if you just have them by themselves, then it's going to be 2 every single time. Nope, it's together. Lithium fluoride. They're connected. Yep, it's one compound. We ready?
Yep.
Okay. So I'm going to rewrite the problem. Lithium fluoride is one compound. So I got lithium and fluorine in this compound. Lithium has a +1 charge, fluorine has a -1. So do they equal? So I don't have to put any extra numbers at the bottom. Cool. So when I give you something like this, just one compound, nothing else with it, it's going to be a decomposition every time. And we can put a D in this box, meaning decomposition. Or you can spell out the entire thing, decomposition, just sound out the word. So the decomposition, what does decomposition mean to you? To break down. Yep. So now, on the other side, we're going to have the 2 parts by themselves, broken down. So we have lithium and fluorine broken down into their 2 components. What's wrong with this? Yes. What is it? Has to have a tube behind it. Yep. So now, I'll do it real quick. It's an easy one. LiF 1, 1, 2, 1. So we're going to double this to get 2 fluorine. So this doubles, and then we're going to double this to get 2 lithium. So it's going to be 2, 2, 1. Did everybody get this? Yeah. If not, I'm guessing that was your error. Yep. So when I give you one word, or 2 words, I guess it is, and it's just lithium fluoride, it's going to be a decomposition every time. Good? Everybody good? Okay. So I'm just going to do this quickly. And And I can give you it like this here before I'm done. I can give you it like this. Same thing, except for I made it easier on you. Now I told you what the formula is for one side. A synthesis would be the other way around. So if I had lithium plus fluorine oh goodness, I spelled it wrong from the beginning. Fluorine, lithium fluorine. Give you something like that. What would that be? What would I put right here? Or, shoot, I'll give you it like this. What would this be right here? LIF. Look at that. LIF. And what would we call this when they're coming together? A synthesis. Yep. Absolutely. And I'd put an S right here. I put an S. Synthesis. They're coming together. It's not breaking apart. Synthesizes to means to create. Synthesis. S-Y-N-T-H-E-S-I-S. Synthesis. Something like that. Cool? All right. So that'd be a synthesis. If I gave you something such as, we're going to use our good old lithium fluoride. Plus hydrogen. Does anybody know what we call this type of reaction? Yeah, single replacement. LIF plus H2. It's going to be a single replacement. And what does a single replacement mean? It means that, or positive, this is a positive one, right? And a positive one. The positives are going to switch. So they're going to trade spots. So now I'd have hydrogen, HF, hydrogen fluoride plus lithium. They're going to switch spots on that negative ion. And then right here, I would do single replacement, SR. Cool? Everybody get that? Leave it up there a little bit longer. All right. We got two more. So again, I'm going to go back to, yes. Yes. Lithium, we go back to lithium fluoride. Fluoride plus hydrogen chloride. Yeah. So LiF plus HCl. You have what would we have on this side then? On the product side. Nope. Switch. What would I have on the product side? H, HF, plus LiCl, hydrogen fluoride plus lithium chloride. And take a guess what I'd put in this box. Double replacement, or DR for short. I don't care if you use the shortened terms or you use the longer terms. I'll use the short term, DR, double replacement, SR, single replacement, S, synthesis, D, decomposition. We got one more, combustion. Just waiting. And it's called a double replacement because, okay, if you remember last time, it was just H. So only one ion was getting replaced. Only the lithium was getting replaced. But if we switch them, so say we have two compounds now. If we switch them, we're replacing this one and we're replacing this one. So that means double. We're doing two of them. It's a double replacement. If it was just H right here, it'd be single because we're only switching it on one compound. Make sense? Okay. Moving on. Last one. In this class, if you ever see a C, doesn't matter what's there, but followed by an H, doesn't matter what's there, plus O2 equals CO2 plus H2O. If you ever see this, no matter if it's a 3 and an 8, I think that works, a 3 and an 8, or a 2 and a 6, or a 5 and a 10, 5, 10, whatever it may be, this will always be combustion. You'll always put CB right away. Or if I put, I could put C for H3, 6, 10, H10 plus blank equals, I don't have to add the rest. You could tell me what to put in the last remaining spots. It's always going to be oxygen. It's always going to be CO2, and it's always going to be hydrogen. So I can just give you this, and you should be able to figure it out. If I give you C with an H, there's that compound. The rest are always going to be oxygen, CO2, and water. That makes sense? It's always going to be combustion. With this, what special do I do? I notice that this is a 4. What's the special thing that I do every single time? Every single time I see a positive number here, what do? Yeah, we double it right away. Make that 2. And it'll make it easier for you down the line. Because otherwise we'd run into troubles with balancing our oxygens on this side. Cool. Everybody good? Tracking? You're doing well. That's it? Nothing? Say that again? The H will always be positive for these, this will always be positive. Just the C. Yep. Good question. All right. I'll be it.